Question 3. This question is phrased in a rather unconventional manner, and that at first you might feel a bit confused about what the question is asking. But be assured that after going through this video tutorial, you will understand this question and that you will realize that you already have the skill to solve this question. Think of the empirical formula and the molecular formula. How do you go about solving or determining the empirical formula when you're given certain percentages of elements in a compound? Let us interpret the question together. We are given the mass percent of the fertilizer, okay, and you are told this: a 30:10 fertilizer means that in 100 grams of fertilizer, one will have 30 grams of nitrogen, 10 grams of P2O5, and 10 grams of K2O. This is similar to the empirical formula of solving questions. What is the next step then? Now, if we have 30 grams of nitrogen, how many moles of nitrogen is that? We will have to take 30, the mass of nitrogen, over 14.0 grams per mole, which is the molar mass of nitrogen. We will get a mole of 2.14. If we have 10 grams of P2O5, we will have 10 over 142.0. This is equals to 0.0704 moles of P2O5. And we do likewise for K2O. Because that is what the question is asking, we are trying to interpret the mass percent of nitrogen, P2O5, K2O in this order. But later on, when we look at the question is not asking for the ratio of the compounds. It's actually asking for the ratio of the elements in the fertilizer. Now for nitrogen is very easy. We have 2.14 moles, but in P2O5, the phosphorus is combined with oxygen, and we have 0.0704 moles of that. So how many moles of phosphorus do we have? The same for K2O. Potassium is combined with oxygen, and we have 0.141 moles of K2O. How many moles of potassium is that? We will have to find out. Okay, so if you look at the mole ratio of the elements, for nitrogen it's very simple. We already calculated it up in the front. It's 2.14. But for P2O5, for every mole of P2O5, we have 2 moles of phosphorus. Now we have 0.0704 moles of P2O5. So the number of moles of phosphorus that we have to multiply by 2. The same thing for potassium. For every mole of K2O, we have 2 moles of potassium. So we need to multiply 0.141 by 2 to determine the number of moles of potassium. So in the end, we get a ratio of 2.14 is to 0.1408 is to 0.280. But again, the question is not asking us for this ratio, but we need to express the ratio of potassium K as 1.0. So we will take 0.282 divided by 0.282 to get 1.0, and we will take 2.14 divided by 0.282 to get a number of 7.6, and we will also take 0.1408 divided by 0.282 to get 0.50. We have to do this because the question requests us to express the ratio of potassium as 1.